Okay, we're going to talk about Lhopital's rule. At the beginning of the semester, we learned strategies to find the solution of problems involving limits. Those strategies included direct substitution, the factoring technique, and rationalizing if the expression had radicals. We first used direct substitution, and if direct substitution resulted in 0 over 0, which is the indeterminate form, we use the factoring method or rationalizing a graph or a table to find the solution. Well, L'Hopital's rule is another strategy we can use for indeterminate form. There are several different types of indeterminate forms, and they are 0 over 0, infinity over infinity, infinity times 0, infinity minus infinity, 1 to the infinity power, 0 to the 0 power, and infinity to the 0 power. But in Calculus AB, we focus only on 2 of them, and that's 0 over 0 and infinity over infinity. So we're going to look at an example and see if we can use L'Hopital's rule on this example. So I have the limit as x approaches 2 of x minus 2 over x squared minus 4. So the first thing we're going to do is direct substitution. So I'm going to substitute 2 in for x. So I have 2 minus 2 over 2 squared minus 4. And that's going to give me 0 over 4 minus 4, which is 0 over 0. So this is indeterminate form. So back when we were doing limits, we didn't know anything about L'Hopital's rule. So we use what we call the factoring method. So we make sure that our terms in our expression were factored. So we have limit as x approaches 2 of x minus 2 over x minus 2, x plus 2. Remember, x squared minus 4 is the difference of squares. So we would factor that as x minus 2 times x plus 2. And we saw that x minus 2 could be canceled with the bottom. So our result would be the limit as x approaches 2 of 1 over x plus 2. And then we use direct substitution again. So we got 1 over 2 plus 2, which is 1/4. Okay? So now that we know something about L'Hopital's rule, we can actually use L'Hopital's rule for indeterminate forms. All right? So I will go back to my original expression, which is the limit as x approaches 2 of x minus 2 over x squared minus 4. So according to L'Hopital's rule, what we want to do is take the derivative of the numerator, which would be 1 minus 0, and take the derivative of the denominator, which would be 2x minus 0, and we would get the limit as x approaches 2 of 1 over 2x. And then we will apply direct substitution, and we would get 1 over 2 times 2, which is 1/4. And you see that that L'Hopital's rule resulted in the same answer as the factoring method. All right, let's try another example. So we have the limit as x approaches 2 of x squared minus 4x plus 4 over x cubed minus 12x plus 16. So the first thing we need to do is direct substitution. So I have 2 squared minus 4 times 2 plus 4 over 2 cubed minus 12 times 2 plus 16. So I get 4 minus 8 plus 4 over 8 minus 24 plus 16. So I'm going to have 0 over 0, which is indeterminate form. So I can use L'Hopital's rule. So with L'Hopital's rule, I'm going to take the derivative. I'm going to write limit as x approaches 2 first. And then I'm going to take the derivative of my numerator, which is 2x minus 4. And then I'm going to take the derivative of my denominator, which would be 3x squared minus 12. All right, then I'm going to apply direct substitution. So I'm going to substitute 2 in for x. So I have 2 times 2 minus 4 over 3 times 2 squared minus 12. I get 4 minus 4 over 12 minus 12. And that's going to give me 0 over 0. So again, I get indeterminate form. So I'm going to have to use Lhopital's rule again. So I'm going to take the derivative of the previous derivative I took. So I have the derivative of 2x, which is 2, minus the derivative of 4, which is 0, over the derivative of 3x squared is 6x, minus the derivative of 12, which is 0. Alright, so I have the limit as x approaches 2 of 2 over 6x. Now I use direct substitution. So it'll be 2 over 6 times 2, which is 2 over 12, which is 1 over 6. Alright, so that's my answer, 1/6. So the limit of x approaches 2 of x squared minus 4x plus 4 over x cubed minus 12x plus 16 is 1/6. And that's it. Excuse me.